Please don't forget to like, subscribe, and comment. Thank you so much.
Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +2348085095144 to learn more and get started today.
This to explain this. Let's look at the definition again. Go back to page 5. You said osmosis is the movement of water molecules from a region of higher concentration of water molecules, lower concentration of water molecules. In other words, where you have more water molecules to where you have less water molecules. And of course, it has to pass through a semi-permeable membrane or partially permeable membrane. This must be included anytime you are defining osmosis. I'm sure you know that. So osmosis is the movement of water molecules from a region of higher concentration of water molecules, which of course will be dilute solution, to a region of lower concentration of water molecules, which of course will be a concentrated solution, through a semi-permeable or partially permeable membrane. Now, when you are defining diffusion, it's just about movement of particles generally from a region of higher concentration to a region of lower concentration. All right, now, next page. If you look at this diagram, look at these sections, these two sections, section A and section B. I use this red dot to represent water molecules. The blue dot to represent salt particles. So this is a salt solution. You know, a solution contains solute and solvent. The solute is the solvent, the salt. The solvent is the water, isn't it? Okay, so in solution A, what do you have more than the other?
You have more water molecules.
You have more water molecules in solution A, less salt particles. And of course, in solution B, you have what?
More salt particles and less water molecules.
Okay, so we can call solution A dilute because it has so much water in it, isn't it?
Yeah.
And we can call solution B concentrated. In other words, it has a lot of salt but few water molecules. Do you understand that?
Yeah.
You know, when a drink is dilute, it has so much water, which is A. When your drink is concentrated, it has little water, which is B. So these two solutions, A and B, do not have the same concentration of water molecules. A has more water molecules than B. That's why water molecules are moving from A to B, passing through this semi-permeable membrane. Okay, and that's osmosis. Now, comparing solution A and B, the one with a higher concentration of the solid particles is called a hypertonic solution. So you can now read what I wrote about hypertonic solution.
Hypertonic solution, comparatively more concentration of solute in the solution.
So B has more salt particles. That's the solute. So it is the hypertonic solution compared to A. Now A is the hypotonic. So read what I wrote about A.
Hypertonic solution, comparatively lower concentration of solute in the solution.
Example A. A has less solute, has less salt compared to B. So A with less salt, more water is the hypotonic solution to B. And B with more salt, less water is the hypertonic solution. So when you have two solutions, hypotonic and hypertonic, what will be the direction of flow of water?
The flow, what do you mean?
You know, you have two solutions. You have two solutions separated by a semi-permeable membrane. one solution is the hypotonic one. The other one is the hypertonic one. In which direction will the water molecules be flowing?
From the hypertonic to the hypertonic.
Yes, from the hypotonic, yes, to the hypertonic, because hypotonic has more water molecules. And you remember, osmosis is the movement of water molecules from a region of higher concentration of water molecules to a region of lower concentration of water molecules through the semi-permeable membrane. Now, that's for hypertonic and hypotonic solutions. Now, there's also isotonic. Isotonic, they have the same concentration, and because they have the same concentration, no movement of water molecules across the membrane, right?
Yeah.
All right. Now you need this understanding to answer practical questions on osmosis. Okay. Before we talk about active transport, I want us to look at this. Go to page 9. Go to page 9.
Can you see that?
Yes, please go to page 9. Page 9.
Yeah.
All right.
Okay.
Some fresh potato chips are placed into two different solutions.
Yeah.
Now, because this will help you to understand this, some fresh potato chips are placed into two different solutions, comma. Now, that potato chip or one of the potato chips will absorb water and swell up if the solution has less salt concentration than the natural concentration of the salt solution in the potato chips. Okay, let me make this clearer. Are you there?
Yeah.
Just imagine you have a potato chip and you place it in a solution, maybe in a beaker, right?
Yeah.
If the salt in the inside the potato is less than the salt inside the...
Wait, is this the osmosis practical?
Yes,
Okay.
I think you must have done something like this.
I remember it in school, but like, if they gave me a question, I wouldn't know how to answer it.
All right. That's why I'm explaining it, because you will need this understanding to answer questions on osmosis. So as I was saying, just think of that potato chip.
Yeah.
The potato chip is placed inside a beaker containing a solution.
Yeah.
Okay, let me see if I can illustrate that with a diagram. No, okay, I think what I would do is use this diagram. Go back to page 6. As I'm talking, I should be showing you this diagram. It will help you to appreciate it.
Yeah.
So think of A as the potato chip. A is the potato chip. B is the solution that it is dropped into. So the potato chip has less salt particles than the salt particles inside the solution. Did you hear me?
Yeah.
Potato chip, which is A, has less salt particles than the salt particles inside the solution. So which direction will the water be going?
It'll be going from
This
would it
is
be going from the right to the left?
the potato chip has fewer salt particles.
Yeah.
The solution has more salt particles. So which direction will water be moving?
From the one with more water particles to one with less.
Exactly, which is from the one with fewer salt particles, that is A,
Yeah.
to the one with more salt particles, that is B, isn't it?
Yeah.
So it means if A is the potato chip will be losing water to the solution. Water will be moving from the potato chip into the solution.
Yeah.
So that will mean that the potato chip will become floppy. It will kind of dry up, shrink, and become flappy
Okay.
because
so
it's
it'll become like soft.
because it's losing water. Yes, soft, because it's going to be losing water. Now,
What's the like? Can you explain the practical?
that's the practical I'm explaining now. You're even going to see it in the question I will give you immediately. I want to give you another scenario. Let's say B is now the potato chips.
Yeah.
B is now the potato chips. So B has more what?
Water molecules.
Are you sure? B has more what?
Oh, sorry, salt molecules, particles.
And fewer water, right?
Yeah.
Than A, and A is now the solution. The
Yeah.
solution that you put the potato chips inside. And A has more water molecules.
Yeah.
So water will be moving from where to where?
The one with more to the one with less.
Assuming B is the potato chip. So water will be flowing from where to where? From the solution into the potato chip, isn't it?
Yeah.
And that would mean that the potato chip will swell up
Yeah. And become soggy and then like.
and
lumpy.
will become swell up, right?
Yeah.
Okay, that's what you get.
Because it swells up, does it expand then?
Yes, it expands. If it is a cell, it can get to a point that it will swell up and even burst and get killed. Some cells can be destroyed as a result of this, and I will tell you there's a name we call it in biology. I'll move to that. Okay, but before we get to that, I want to clean up this slightly and ask you to fill it in. So go think about what I just said and go to page 9 again and read this. You're going to supply the proper word in where I circled in blue.
Okay.
You read it, think about it before you supply the right words. The right words will be less or more. You're going to use less or more.
Okay. So when some fresh potatoes chips are placed into two different solutions, it absorbs water through its semi-permeable membrane. If the solution has something to itself too much.
You mean more salt concentration than the natural concentration of the salt solution in the potato, right?
Yeah.
Okay, so the potato chip will absorb what? Are you sure? Are you
Wait,
sure?
if the
Are you
solution
thinking?
has too much salt concentration, then the natural concentration of
Are you sure you're thinking about it? When will the potato chip absorb water and swell up?
when it has too much water.
Are you sure? If it has too much water, will water be flowing into it?
No, like when it absorbs too much water.
When will it absorb water?
When
You really need to be ready to think. Oh, this is a thinking class. I hope you have avoided every distraction because you're going to think here. Go ahead. Let me give you a second to think through it. Okay. So
yes, it absorbs water because
I'm talking about the potato chips. When will the potato chip absorb water?
when the water molecules.
If the solution has what salt concentration than it?
So did I say it right?
Say that again.
Solute.
when it has what? More or less salt particles?
Less.
Okay. If the solution has
Yeah.
less, and why did you choose less?
Because if it has less salt concentration, then it has more water particles, which causes it to swell up and absorb water.
Exactly. If the solution has less salt particles,
Yeah.
it means it has a lot of water in it, isn't it?
Yeah.
Compared to the potato chip. So the solution has a lot of water. The solution has a lot of water.
Yeah. And it has less salt.
It has less salt. So water will be moving from the solution into the potato chip.
Yeah.
That's exactly what we explained in question number 5, in page 5. Water, in this case, the potato chip is like B. The solution is like A. You can go back there and verify. In this case, the potato chip is like B. You can go to page 5 and verify what I'm saying. Yeah, the potato chip is like B with so much salt solution, few
Yeah.
water with so much salt particles, few water molecules. And the
But
solution,
in the practicals, because obviously you do it with potato, but could they use anything else?
yes, you can use anything else. You can use
But
anything.
would it always be salt particles and water molecules?
Yes, it will always be in a solution that contains some solutes. It could be sugar solution, it could be salt solution, or any other solution.
Oh, okay. Would it tell me though?
All these questions we have include that. Whenever that kind of question is given, it will include that.
Yeah.
All right, so take note of that. And then the other part of the question is B. You go back to it again. B. Now, the potato chip can lose water and shrink through its semi or partially permeable membrane if the solution has more concentration of salt.
Yeah.
Because if the solution has more concentration of salt, it means it will
When
have,
has more concentration, then it has less water.
it has less water. So water will be moving from the potato chip into the solution, right?
Yeah.
So the potato chip will be losing water and shrinking and become flappy and soft.
Yeah, soft.
All right. Okay. All right. So that's that. That's what this practical is about, and that's how the questions are tailored.
I hope it gives a question like this because sometimes it gives a question on like, say all the independent variables, say the variables of this.
Yes.
Practical, or say how to do this practical.
And something like that. Of course, you will need to know which one is the independent variable and which one is the dependent variable. I will like give you an example of a practical like that. In fact, just hold on, I'm going to it. We will meet it. Maybe if not in this particular topic, another topic. I will show you all of that. I just don't want us to mumble up what we're talking about. Read this. I told you this same thing happens in the blood.
Hypertonic solutions lead to cell swelling and eventual rupture of lysis if the resultant osmotic movement of the water is great enough. In the case of red blood cells, this is referred to as hemolysis. If placed in a hypertonic solution, it will shrivel, making the cell.
Okay, let's talk about this. Let's talk about when blood cells, red blood cells, for instance, are placed in a hypotonic solution.
So, wait. If red blood cells are placed in a hypertonic solution, then
Hypotonic solution means that solution has
a lot of
water. Remember, we said that a lot of water, right? You can go to page
a lot of water and fewer like
salt. Yes.
yeah, salt.
that solution has a lot of
And
water.
then the other one, the other one, doesn't that have less water and more?
So more solute. So
Yeah.
red blood cell is placed in a solution that has a lot of water.
So that means it will absorb a lot of water and become soft.
Okay. So water will be moving from where to where?
From the solution to the
Red blood cell.
yeah.
Water will be moving from the solution into the red blood cell, causing the red blood cell to swell up.
Yeah.
And that's what we call hemolysis.
Oh, okay.
Okay. Then if it is the other way around, you can read it now.
Then if placed in a hypertonic solution, it will shrivel, make the cytoplasm dense, and its tends to concentrate and may die.
Okay, in another case, if the red blood cell is placed in a solution with fewer water molecules compared to the red blood, water will be moving from the red blood into the solution, isn't it?
Yeah.
And so the red blood will shrivel
Because it's losing all its water.
because it's losing water and also may die.
Yeah.
In fact, these things happen in the human body. That's why
Why
the
do red blood cells need water?
pardon?
Do red blood cells need water?
There's fluid in our body now. The red blood cells, they're all suspended in a fluid, in a liquid, water in particular.
Oh yeah.
The entire blood itself contains red blood cell, white blood cell, plasma, and all that. So they are all suspended in a liquid, in water, in a fluid. So if the plasma or the fluid has a lot of water in it, water could be moving from the fluid into the red blood cell,
Yeah.
which causes the red blood cell to swell up.
Yep.
Or in some cases, the red blood cell might begin to lose water
Yeah, and it will shrivel.
and shrivel. Now, have you heard of isotonic drinks?
Drink.
Isotonic drinks. You must have seen certain drinks they write isotonic drinks. They
Is
usually,
it like energy drinks?
yes, they usually serve
Yeah,
those,
yeah.
give those drinks to sports people. So what does that tell you? Go to page 6 of 20 so that you understand what isotonic drinks really mean.
Okay.
So what do you think isotonic drinks are?
Same concentration, so no movement of water molecules across
So
the membrane.
yes, it has the same concentration as the red blood cell or any other medium. So there's no movement of water from the solution to the medium or from the medium into the solution.
Yeah.
I just need to tell you this. Especially during an accident. If an accident occurs and a patient loses a lot of blood,
Yeah.
you need to be careful the kind of fluid such a patient is given. You may give the patient some water that may cause the remaining red blood cell to begin to absorb that water and swell up and cause much of the red blood cells to die, reducing the already depleted red blood cell of the patient.
So the patient having water increases the amount of water they already have in the body.
Not necessarily, it's not about having so much water. I'm talking about the concentration of. Okay, you are still on this same page. It's not necessarily about how big the container is. It's about how much of water compared to the other
The
medium.
ratio.
Yes, the ratio compared to the other medium we are using as the basis for the comparison.
Yeah.
It's not about size. If you think of a red blood cell of this size, you can see what I'm circling,
Yeah.
and then you think of a solution of this same volume, a red blood cell of this volume, and a solution of this volume. So we are interested in how much water molecules are inside this red blood cell of this volume compared to a solution of this same volume. So it's about ratio, like you said, not necessarily the size of the water.
Okay.
So this is more important. It's a more important consideration, especially when a patient has few red blood cells, because you should be very careful not to kill the remaining red blood cells. They're already depleted red blood cells, so you are careful about the kind of liquid you give the person.
How does a person have like only a few blood cells left?
And that's what I'm saying. Someone in an accident that loses a lot of blood. Maybe there was a cut and a lot of blood has been lost. So you should be careful the kind of fluid he or she takes, so that the remaining blood cells are not damaged, either by swelling up because they are absorbing liquid,
Yeah.
or by shrinking because they are losing liquid. So
Yeah.
an isotonic drink would be the best option at that moment.
Oh, okay.
Now
so
these
when
are-
a person is losing red blood cells, they should drink isotonic
Yes,
drink.
it's very important that they don't just drink any kind of drink, because it may trigger another rapid loss of blood cells, which can now result to something more critical.
What's the hazard of this practical?
Pardon?
What's the hazard of this practical?
What?
Like a hazard, like a mistake or an error.
Yes, when it happens, that's why when in an emergency situation like this, they say doctors are mindful of the kind of fluid they give the patient, and of course, like I told you about sports people, they need a lot of blood for aerobic respiration, even because they need energy, quick release of energy.
Yeah.
So when they are taking their drinks, those special drinks, isotonic drinks, are preferred. That will not cause them to lose some red blood cells, which will reduce aerobic respiration and less energy.
Yeah.
All right. I'm happy that you've seen isotonic drinks. You have some of those brands in the market.
Yeah.
All right. So that's about that. And of course, page 7 is about active transport. Active
Yeah.
transport is the movement of particles from a region of lower concentration of the particles to a region of higher concentration of the particles. And because it is against concentration gradient, it requires energy. So there has to be an addition of energy. Concentration gradient, natural concentration gradient, is always from higher concentration to lower concentration, isn't it?
Oh, so this isn't natural.
Yes, natural. Of course, a ball will roll down from the top of the steep to the bottom of the steep naturally. If you let the ball roll, it rolls.
Whereas active transport needs energy.
Yes, but if you want to move the ball up means against concentration gradient. You need energy, right? So active transport requires energy, and like you said, that's what happens in root hair cells. Because in root hair cells, let's go there. In root hair cells, go to page 10. You're there.
Yeah.
Read it out.
The sustained absorption of mineral ions from the soil into the root hair cells, even when there are more particles of the mineral ions already inside the root hair cells than inside the soil, lower to higher concentration.
Okay, you see, the plant keeps absorbing minerals ions from the soil
Yeah.
through the root hair cells into the roots. Now, even when you have more mineral ions inside the root than in the soil, the plant is still absorbing the mineral ions.
Okay.
That means from the soil, which has a lower concentration of mineral ions, into the root, which already has a higher concentration. So you need energy.
Yeah.
So it's from lower concentration to higher concentration. So energy is required. That's one natural example of active transport. And you can go to page 8 where we talked about natural occurrence of diffusion.
Yeah.
In
Photosynthesis.
in photosynthesis, in gaseous exchange, where CO2 moves from a region of higher concentration into the air, like into leaves where there's less CO2. Okay, in gaseous exchange in leaves, where carbon dioxide moves from a region of higher concentration, that is from the air, where you have more carbon dioxide.
Oh yeah, through the leaf, yeah, and then it come out through the stomata or something.
Yes, all of these things occurs through the stomata. We'll talk about that. All right. So into the leaves where there is less CO2. So it's actually from higher concentration outside, that's in the air, to lower concentration, which is inside the leaves. Higher to lower inside the leaves. Now, similarly, oxygen moves from the leaves where you have more molecules of oxygen. In the leaves, you have more molecules of oxygen, and then it moves into the air where you have less molecules of oxygen. So it's a natural process. Diffusion is according to concentration gradient. It is not against concentration gradient. In fact, diffusion is along the concentration gradient.
Oh, okay.
Also, in gaseous exchange at the alveoli, in the lungs, where oxygen from the lungs is absorbed into the blood, because you have more oxygen in the lungs than inside the blood. So it moves from a region of higher concentration in the lung to the region of lower concentration inside the blood. And then at the same time, carbon dioxide diffuses out from the blood into the lungs. In the blood, you have a lot of carbon dioxide, more concentration, that's higher concentration. Then in the lungs, you have less.
Isn't that active transport?
Pardon?
Isn't that active transport then?
No. I mean, in the blood, you have a lot of carbon dioxide. I'm talking about I'm done with oxygen. Oh. I said oxygen moves from lungs into the blood.
Okay.
And you have more of oxygen in the lungs than inside the blood. So it goes from higher concentration to lower concentration, which is normal diffusion, along concentration gradient. At the same time, carbon dioxide moves from the blood into the lungs. Carbon dioxide moves from the blood into the lungs. In the blood, you have
Is it because the blood has a lot of carbon dioxide?
exactly,
Okay.
and the lungs has less carbon dioxide, so it also diffuses out.
Yeah.
If you remember what I told you when we were looking at respiration, I told you respiration takes place at the level of the cell, where oxygen combines with glucose to form water
Oh, yeah, water
and carbon dioxide.
carbon dioxide, yeah.
And of course, energy is released. That's aerobic respiration. So that carbon dioxide and water will need to be taken out of the cells where they are produced, and they flow into the blood again through the capillary and then into the veins. The veins carry them to the heart, and then from the heart they move to the lungs through the pulmonary. You remember pulmonary artery?
Yeah, on the heart artery.
Pulmonary artery, they go into the lungs, and then it's from the lungs that the carbon dioxide and water vapor will be expelled or released,
Yeah.
because you have a lot of carbon dioxide in the blood. So the blood is the transport system for all these processes. Okay, this makes sense now. We can go back to the question
Okay.
on page 11.
Yeah.
So he says the student measured the mass of 4 of the potato sticks using an electronic balance, right?
Yeah.
The student left each potato stick in one of 4 different liquids for 5 hours. So
Yeah.
each potato chip or stick is placed in this liquid A, B, C, D.
But you know the distilled water, we don't know, like...
The distilled water is like the control variable, the controlled experiment. You know, where there's no...
It's always there.
Yes, something to show us what will happen if those factors were not involved.
Yeah.
Okay, for instance, B has 0.1 mole per dm cube of sodium chloride.
Yeah.
C has this mole per sodium chloride. Which one is the most concentrated of all of these? B, C, or D?
D.
D is the most concentrated. D has a lot of salt, isn't it?
Yeah.
And less water. So let's even be explaining it like this. D has much salt, less water, isn't it?
Yeah. So I would be D because it has less water. So that means the potato stick size would decrease because it's giving out the water.
All right. It says, predict which of the liquid will cause the largest decrease in mass of potato stick. So
Yeah. So what point
is D. D that is the most concentrated has less water. So water will be moving from the potato stick into the solution. So it will happen much more in D. You know, the potato chip has more water molecules, more concentration of water molecules compared to all of these. So water will be moving from potato chip into each of these solutions, but it will be much more in D. So you see making sense now?
Yeah.
Beautiful. So it says predict which of the liquid will cause the largest decrease in the mass of the potato stick. Solution 1.0 mole per dm cube. And you know the reason. Okay. Now look at this. It says the student, read it out.
The student dried the potato sticks with the paper towel before putting them on the electric balance. Suggest why? Because the potato stick has excess water, which will affect the mass.
What you mean is, you know, when you bring out the potato chips, there might still be water attached to the body because it's wet. So you need to dry so that you don't take into you don't account for those other water, you know. So basically to clean up the water particles or molecules, if you like.
Could you say to remove any excess solution?
Excess solution, yes, to clean up the water molecules, or remove excess water stuck to the potato chips. Stick. Next question.
After the experiment, the student noticed that the potato stick with the lowest mass was soft and floppy. Explain why the potato stick had become soft and floppy. The potato stick became soft and floppy because it had taken in a lot of water due to...
Did you mean it took in? Did you mean it took in? It became soft and floppy.
Because it took in...
Did it take in? If it takes in, it would become turgid. It will swell up and become turgid. But it became soft and floppy.
Yeah.
It lost water.
Yeah, because the potato stick with the lowest mass has less... The solution had less water.
Yes, so the potato chip has lost a lot of water.
Yeah.
That's a 3 marks question. So you need to talk about it referring to osmosis. So the
water molecule concentration went from an area of higher concentration to an area of lower concentration, so inside the potato to make it swell up.
all right. So the potato didn't swell up, but it became soft and floppy.
Oh,
So it lost water. The potato stick lost water to the solution through its membrane.
Yeah.
You can even add semi-permeable membrane. Let me zoom this in a bit so that we can capture this properly. Because it has more water concentration than the solution. So something like this can pass for that explanation. Okay? All right, let's go to the next page. We won't talk much about this. I just want to show you something. This is also something similar to this, right?
Yeah.
It says explain. Just look at this. Something happened. The student note. Just read this part.
The student added some iodine solution to the water in the test tube. After 30 minutes at room temperature, the contents of the whisking bag were stained blue black, but the water outside remained a yellow color.
Okay.
Isn't that like food? Wait, what is it? The food practical?
The what? Diffusion practical?
No, I swear that's the food practical where you're like testing for like sugars and starch and that.
No, not necessarily all those experiments. You know, this is about osmosis.
Okay.
It's about osmosis. It's exactly the same. I just didn't want us to waste time. I will show you by the time if we because you know we need to move on to something else. There's also a higher concentration of water molecules inside the test tube than inside the whisking bag. So by osmosis, water molecules are moving into the whisking bag. Okay, look at the whisking bag. If you look at it here,
Okay.
and look at water inside the test tube.
Yeah.
The skin of the whisking bag is like the semi-permeable membrane.
Yeah.
So I said the test tube is one medium. Inside the whisking bag is another medium. The skin of the whisking bag is like the semi-permeable membrane. So water can move from inside the whisking bag into the test tube, or from the test tube into the whisking bag, depending on the difference in concentration of water molecules. But in this case, if you study this question, you will see that can you read what I wrote in yellow?
There's a higher concentration of water molecules inside the test tube than inside the whisking bag. So by osmosis, water molecules are moving into the whisking bag.
Okay, so by osmosis, water molecules will be moving from the test tube inside into the whisking bag, right?
Yeah.
Coloring it. If you read, you take your time and read through, and then you will understand. Because I don't want to repeat all the explanation I've given you earlier. It's just the same principle. Then this one says state 3 factors that influence the movement of molecules through the membranes.
Temperature, surface area of the membrane, size of the particles, and thickness of the membrane.
Yeah, I just gave you 4. Any of these can, with higher temperature, the particles have higher kinetic energy, so they can move, and spread better. So with a higher temperature, there will be a greater movement of molecules through the membrane. With a larger surface area of the membrane, there will be a greater movement of molecules through the membrane. And if the thickness of the membrane is smaller, there's an easier passage of the water in or out of the whisking bag, right?
Yeah.
through the membrane. And of course, the size of the particles. If the size of the particles is smaller, they can easily move through. So these are factors that affect osmosis and even diffusion.
Diffusion, okay.
Yeah. All right. Just
Shall
read
we
this.
go to
Read this so that we can move away from here. State 2.
Okay. Diffusion goes from high concentration of
No, not at 3A on the page 12 of 20.
State two features of diffusion that do not apply to active transport. Diffusion goes from higher concentration of particles to lower concentration, while active transport goes the other way. Diffusion does not require energy, but active transport requires energy.
Then it says, explain how roots are adapted to absorb ions.
Large surface area, thin walls of membrane.
In fact, this is the same thing. Of course, large surface area, thin walls of membrane. This is exactly the same thing you find in alveoli. Alveoli, the walls of the alveoli has a large surface area
Yeah.
to enable gaseous exchange. Gaseous exchange is oxygen being absorbed into the blood and carbon dioxide being diffusing out of the blood. The carbon dioxide diffusing out of the blood. Then the walls of the alveoli is also very thin. In fact, both alveoli, root hair cells, and the villi in small intestines have these common features. The villi, where digested food nutrients absorb into the blood, also has a large surface area and thin walls, and also moist. You can also add is moist if you like. All of these things will get you the same answer. I will get you the answer is moist to enable absorption. All right, maybe at your spare time you can do the question in the next page. It's a question in the next page where you are asked to calculate percentage,
Yeah.
using this formula. I just provided this formula to make it easier, and with this you'll be able to do the one on the right hand side, which asks, you can see.
Yeah.
You will understand this by the time you practice it.
Can I quickly go toilet before we go to the next part?
That's fine.
Please don't forget to like, subscribe, and comment. Thank you so much.
Welcome to Like Learning School, your premier online education platform. At Like Learning School, we are dedicated to helping students and learners unlock their full potential, providing them with the foundation, support, and guidance they need for academic excellence. Our platform caters to two main target audiences. Firstly, we work with school children of all ages, offering academic follow-up and accountability partnerships. Our seasoned tutors provide personalized attention to ensure students stay on track and reach their goals. Secondly, we support students and learners who are preparing for internal, external, entrance, or professional examinations. We offer comprehensive and well-structured support to help them achieve outstanding performance in their exams. Our robust virtual courses are designed to keep students engaged and motivated. With interactive videos showcasing our teaching sessions, students actively participate in the learning process, making education enjoyable and effective. But that's not all. We believe in personalized education. Our students have access to personalized tutorial sessions, whether online, physical, or hybrid, tailored to their unique learning needs. Join us at Like Learning School and experience a transformative education journey. Visit our website at www.likelearningschool.com or contact us at +234 808 509 5144 to learn more and get started today.